All right, this is the first lecture in a review section previous to differential equations. This general course is about differential equations, but there are some topics that I want to make sure are covered before I get into the meat of differential equations. And we're going to go objective at a time. This objective is going to determine, we're going to determine whether a function is even or odd and identify symmetry. So most of these are going to be coming from pre-calculus and calculus. And we're going to get harder as we move towards differential equations. I just want to make sure that option is there so that you have the option to go back and learn this in case in the future when we get somewhere I can, one, reference this video, and two, make sure it's covered properly so that you have a good grasp on this. So a function is even or odd. A function is even if f of x, function f of x is even if we replace everywhere in the function, we replace x with minus x, and we get the same function. This is the definition of an even function. And one way to notice without doing this, sometimes you have to do this, like for instance sine and cosine are even and odd, and you may not remember that off the top of your head, but if you replace cosine minus x, it is the same as cosine x because cosine is an even function. But that may not be obvious from looking at it, but this identity is just something that you may need to know. So cosine is even. But generally, if I have a function, let's just say we got a function g of x is x to the fourth plus x squared. And you'll kind of see where the word even comes from because all of the exponents are even. And 9 times out of 10, this is going to tell you that you have an even function. And let's prove it. So if I take g of minus x and I substitute that in, so we'll have minus x to the fourth plus negative x squared. Recall that a negative power to the fourth is just positive, so this first term is just going to be x to the fourth, and this one is going to be x squared, and that is indeed equal to g of x. Therefore, g of x is even. Okay. Let's look at an example of odd. F of x is odd. A function is odd if the same thing is we replace x with negative x, but the result is not f of x, but negative f of x. Negative f of x. So, the example of this is sine. Sine of negative x is equal to negative sine x. And we can show this on the graph. I'm going to graph both of these kind of crudely. So if we have sine x looks like this, just a crude graph here, and I want to make sure I get some of this here. Now notice that right here, whatever x it is, on the same side, on the opposite side of the origin, the same distance, say this distance and this distance, they're the same. So this would be f of minus 1, maybe, and this could be f of positive 1. Notice the only difference is this distance is also the same. So the thing is their signs are different. Now there's a special kind of term for this. We call this symmetric to the origin. So we can say sine x is symmetric to the origin. And then what about cosine? Well, cosine's the same function, it's just shifted over, so we can just, this is a crude graph of cosine. Now, notice that here, in the same way, say this distance is 1, and this distance is 1. So this would be f of minus 1, and this would be f of 1. Notice they're the same. So f of minus 1 is equal to f of 1, right? So this function is even, and we call this symmetric about the y-axis. Because this is the y-axis, if I fold this over, if I fold this over, it reflects. It's a reflection across. Look at here. These points are the same there, and so on. Okay. Now there's another case that we kind of need to look at with polynomials, if you'll excuse me as I scoot this up a little bit. And that is neither. So let's look at a few examples here and determine the symmetry. The first one I want to look at is f of x is equal to x cubed plus x plus 1. Okay, now, from looking at this, you would think, okay, both of these, this is x cubed and this is x to the first power, both of these are odd, so that means it's symmetric about the origin and it's odd. But that's not the case. So let's find out what f of minus x is. F of minus x is negative x cubed plus negative x plus 1. Now, this indeed becomes minus x cubed, and this becomes minus x, but this sign doesn't change. Therefore, f of x does not equal f of negative x does not equal f of x, and it does not equal negative f of x. So we say that this is neither odd nor even. So, and the reason why is because if you really put this in exponential format, it's 1x to the 0, and 0's even, so you have 2 odds and 1 even power. So if you had f of x is equal to x to the 4th plus x squared plus 1, this is even, and I'll let you prove that on your own because I already did most of the work up here. You would see that this doesn't change either by changing minus x. Okay, one last example. And we're going to look at f of x, a function, let's change letters, h of x. H of x is equal to x times the square root of 1 minus x to the 4th. And I want to determine the symmetry on this. Now you might want to graph this on your own just so you can see what it looks like. That's up to you. It is kind of a circle looking thing, but that grows because of this. So, but it's restricted between 1 and negative 1, so it's kind of a little crazy. It's a crazy little function. But all I'm concerned is what's its symmetry. What's its symmetry? This is an x. Okay, so I'm going to find h of negative x. So h of negative x is negative x times the square root of 1 minus negative x to the 4th, which is negative x times, so this isn't going to change, but this is going to become positive again. And that is the ideal sign that we have negative h of x. Look, it's the exact opposite of what we just started with. The only difference is the sign change. So this function is odd, and it's symmetric about the origin. Okay, so that's going to conclude the first lecture. I want these to be short and sweet, just little topic reviews. The next topic is coming up soon. I appreciate you watching. If you need further tutoring, check out the links in the description below, and we will see you in the next video. Thanks for tuning in.